The world's most advanced telescope took another leap forward this afternoon as its mirrors were unfolded a million miles from Earth. It's just captured an object racing through our solar system at impossible speeds, cataloged as 3I Atlas, an interstellar comet. But Webb's high-resolution image revealed anomalies that comets simply don't have. What if this isn't a comet at all? And what happens when it vanishes behind the Sun in October 2025? Let's dive into. Throughout history, there have been discoveries that invite us to pause and reflect, and this may be one of those rare moments. The James Webb Space Telescope has achieved something remarkable. It captured the first authentic image of an object that could reshape how we understand our place in the cosmos. Known in official records as 3I Atlas, it has been identified as an interstellar comet. Yet questions naturally arise: what if this object is more than just a comet? Could it be something crafted with purpose, perhaps even a vessel, disguised within ice and dust as it journeys through our solar system? Years ago, Stephen Hawking reminded us of the possibilities and risks of reaching out to distant civilizations, suggesting that our signals might eventually be noticed. For generations, humanity has broadcast its presence into the cosmos, and now we may be witnessing a response. What the James Webb has observed is not only unusual, it could be the most compelling indication yet that we are not alone, and that this encounter has been in the making far longer than we ever imagined. The James Webb Space Telescope has given us something truly extraordinary: the first detailed image of 3I Atlas. This is not simply another achievement in astronomy. It represents a turning point in our effort to study the mysterious travelers that occasionally sweep into our solar system from the depths of interstellar space. In the past, such objects appeared only as fleeting streaks of light, vanishing before telescopes could capture them in meaningful detail. Now, Webb has changed that. Its high-resolution imaging has provided clarity on a scale never seen before, clarity that extends beyond the visual, into the scientific. For the first time, the features of this cosmic visitor are revealed in ways that invite both wonder and deeper investigation. The trajectory of 3I Atlas confirms what astronomers suspected: its origin lies far beyond our solar system. Webb's precise measurements show it following a hyperbolic path, entering our neighborhood once before moving on, never to return. Unlike comets bound to the Sun's gravity, Atlas is a true interstellar traveler. Thanks to Webb, this one brief passage has been captured in unprecedented detail. This fleeting visit highlights why the Webb telescope is so vital. Without its advanced instruments, Atlas might have passed with only vague observations, little more than a blurred entry in astronomical records. Instead, it now becomes a cornerstone in our understanding of interstellar objects, their birth, their journeys, and their survival across unimaginable distances. The image itself carries Webb's signature sharpness, presenting Atlas in a way that earlier technology could not achieve. When Oumuamua and 2I Borisov swept through, astronomers were limited to modest glimpses, trajectories, compositions, and hints at their nature. But the deeper story of their structure remained elusive. With Atlas, Webb's infrared eyes have unlocked new dimensions. Free from the distortions of Earth's atmosphere, the telescope detects faint glows and subtle contrasts invisible to ground-based observatories. The result is breathtaking, not a faint streak lost in the stars, but a clearly defined body, complete with visible surface patterns, spectral signatures, and even a shimmering coma of outgassing particles. When astronomers first recorded 3I Atlas, it appeared to be nothing more than another comet drifting in from interstellar space. Yet the James Webb Space Telescope's extraordinary precision revealed details that challenged this assumption. Its structure, surrounded by an unusual dust cloud, displayed characteristics not typical of ordinary comets. Even more striking was its trajectory, perfectly aligned with the orbital plane of the planets, a level of precision rarely produced by natural processes. To appreciate the scale, consider its velocity, fast enough to cross the United States in under 2 minutes. But speed alone wasn't the surprise. Its path wove deliberately past Venus, Mars, and Jupiter, each encounter using their gravity to adjust direction, a technique space agencies carefully design years in advance for ambitious missions. Statistically, the chances of this happening by coincidence are incredibly small. which led Harvard astrophysicist Avi Loeb and his team to suggest that 3I Atlas might not be a simple fragment of rock and ice, but perhaps something created with intent. What adds another layer of fascination is its timing. The object's closest approach to the Sun, its perihelion, will take place while Earth is on the far side of our star. For several weeks in late October 2025, the brilliance of the Sun will conceal it completely from telescopes and tracking systems. In astronomical terms, that interval represents a perfect window for unseen changes to occur. During that hidden passage, any subtle propulsion, if present, could alter its course with remarkable accuracy, beyond the reach of our instruments. By the time it emerges from the Sun's glare, its path could be entirely different. Natural bodies cannot perform such maneuvers, but an advanced probe, cleverly concealed, certainly could. Loeb and his colleagues emphasize that the alignment of timing and trajectory should not be dismissed lightly. Rather, they view it as an extraordinary opportunity to explore whether this interstellar visitor is simply a comet or evidence of something far more sophisticated. And before we continue unfolding this fascinating discovery, be sure to subscribe and hit the bell so you don't miss any future episodes. Don't forget to share it with your friends too. It helps the channel out, and I'm excited to continue bringing you more awesome content. The image of the 3I Atlas is remarkable not only for what it shows but also for what it reveals about the James Webb Space Telescope's capabilities. Webb's 6.5-meter segmented mirror was engineered to capture faint, distant phenomena, early galaxies, nebulae, and the atmospheres of exoplanets. Yet its precision has instead brought into sharp focus a lone visitor from beyond the Sun's reach, offering a perspective that feels both vast and immediate. This capture demonstrates the telescope's versatility. Webb can decode the glow of galaxies billions of light-years away, yet it can also resolve the fine details of an object passing briefly through our solar system before vanishing forever. In doing so, it bridges the cosmic with the local, the ancient with the fleeting. Particularly striking are Webb's mid-infrared observations. Unlike visible light, which shows only surfaces, infrared reveals thermal contrast beneath thin layers of dust. From this data, astronomers can identify patches where volatile ices are sublimating, releasing jets of gas and particles. These bright regions mark areas of concentrated activity and allow researchers to model Atlas's internal structure and chemical makeup, offering clues to how it formed and survived its interstellar journey. Webb's precision also highlights Atlas's rotation. Subtle variations in surface brightness suggest it does not spin in a simple, steady way, but tumbles chaotically. This irregular motion may have been triggered when the object was ejected from its home system or shaped by countless impacts and outgassing events across millions of years. Such behavior contrasts with the stable rotations of many solar system bodies, providing valuable insight into how interstellar objects evolve dynamically. The coloration revealed in the data adds further depth. Some regions appear coated in carbon-rich compounds that absorb sunlight, while others reflect more brightly thanks to water ice or silicate minerals. The result is a patchwork surface, a geological quilt assembled from different environments in its parent system before being cast adrift. Perhaps most intriguing are the exotic organic molecules detected in Webb's spectra. Unlike those familiar from comets in our solar system, these compounds carry signatures that hint at formation under conditions unlike anything nearby, different stellar radiation, unique elemental abundances, or extreme temperatures. Some may even represent entirely new chemical structures. For chemists and astrobiologists alike, these findings are profound. They suggest that complex organics, the potential building blocks of life, are not confined to one planetary system but may be widespread across the galaxy. If so, the seeds of life could be far more abundant than once thought, waiting for the right conditions to flourish. The trajectory of 3I Atlas is as revealing as its image. Its hyperbolic path through the solar system confirms its interstellar origin and allows scientists to retrace its journey. By combining Webb's precise measurements with ground-based data, astronomers can project its motion backward, linking it to stellar regions where it may have formed. Early studies suggest Atlas was likely ejected from a star-forming region millions of years ago, traveling undisturbed until its encounter with our Sun. This story connects the object to galactic-scale processes, where stars and planets shape one another through gravity, occasionally casting fragments into interstellar space. In this sense, Webb has captured not just an object, but a moving piece of galactic history. Atlas has also struck a cultural chord. Humanity has long looked skyward for meaning, but interstellar visitors like this provide a tangible bridge to distant systems. To study Webb's image is to see a fragment of another world delivered into reach. For scientists, it is data. For artists and thinkers, it becomes a symbol of migration, endurance, and journeys across unimaginable distances. The scale of Atlas raises important scientific questions. If such a large body can survive a crossing between stars, how many others are drifting unseen through the galaxy? Their presence could reshape our understanding of cosmic abundance, suggesting that interstellar wanderers are far more common than once thought. This realization carries profound implications for Earth's own story. It is possible that ancient interstellar objects once struck our planet, delivering chemical ingredients that contributed to the rise of life. Webb's image of Atlas therefore represents more than a passing encounter. It is both a scientific milestone and a reminder that the seeds of life itself may have been carried across the stars by travelers like this one. While the first image of the three-eye Atlas sparked worldwide intrigue, it was the follow-up spectral data from the James Webb that truly shook scientists. By splitting the object's light into its component wavelengths, Webb revealed something it shouldn't have: traces of metals and compounds that simply don't match any known cometary body. Certain reflective patterns resembled engineered alloys, the kind you would expect on the surface of a spacecraft, not in the frozen shell of a wandering rock. Even more troubling was the detection of faint but consistent heat anomalies buried within its icy cloak, as though something inside was generating energy. The temperatures were too stable to be explained by sunlight alone, suggesting an internal power source. For Loeb and his colleagues, this wasn't just a hint. It was the closest thing to a fingerprint of artificial origin, hidden in the noise, waiting for those who dared to look deeper. The implications are staggering. If these readings are accurate, we're not looking at a natural object at all, but at technology from another star system, possibly another civilization. The metallic signatures detected by Webb's spectrometers show isotopic ratios that don't match anything in our solar system. These aren't the random mixtures you'd expect from natural formation processes, but precise compositions that suggest deliberate engineering. Some of the detected elements are rare earth metals, the kind used in advanced electronics and propulsion systems here on Earth. What's even more intriguing is the pattern of these metallic traces. They're not randomly distributed across the surface, but appear to follow geometric arrangements, almost like circuitry or structural frameworks hidden beneath layers of accumulated ice and dust. This geometric precision is something nature rarely produces, but intelligence designs routinely. For scientists working on Webb, this moment validates decades of effort. The telescope was designed not only to peer back in time to the early universe, but also to examine objects within our own galactic neighborhood with unrivaled detail. Capturing Atlas blends those missions beautifully, a local observation with cosmic implications. Every pixel in the image is hard-earned, the product of precision engineering, flawless deployment, and patient alignment. To see it pay off with such a discovery is a triumph for the entire scientific community. The technical achievement alone is remarkable. Webb had to track a fast-moving object across multiple observation sessions, compensating for its motion while maintaining the stability needed for high-resolution imaging. As researchers continue to analyze the data pouring in from Webb, more layers of the three-eye Atlas's story will come to light. Already, models of its thermal properties, rotation, and surface erosion are being refined. Every aspect adds to a growing portrait of an interstellar visitor, not just as a curiosity but as a critical data point in understanding the galaxy's restless dynamics. The image Webb revealed is not a conclusion, but a beginning, a foundation upon which years of study will be built. The wonder of the three-eye Atlas is not only in its uniqueness, but in what it represents. It is proof that interstellar space is not empty but alive with travelers, each carrying a story from a different star. Webb's image crystallizes that reality in a way words alone cannot. For the first time, humanity can look at an interstellar object and see it clearly, with detail that makes it real and present rather than abstract and theoretical. That shift from the unknown to the tangible is transformative. At a human level, there is something deeply humbling in Webb's achievement. To know that light from an object formed around another star has been captured and rendered into an image we can see today connects us more deeply to the cosmos. It reminds us that we are part of a galactic web of matter in motion, that our solar system is but one node in a sprawling stellar tapestry. What makes 3I Atlas even more unsettling is its timing. Its closest pass to the Sun, its perihelion, will occur when Earth is on the opposite side of our star. For several weeks in late October 2025, it will vanish completely from our sight, hidden in the Sun's glare. No telescopes, no radar, no tracking. In space terms, that's the perfect window for something under intelligent control to make a move. Imagine it. In those silent, unobservable days, its hidden propulsion could fire, altering its course with surgical precision, completely undetected. By the time it reappears, it could be on an entirely new trajectory, and we wouldn't know until it was far too late. This is the kind of maneuver that would be impossible for a natural object, but trivial for an advanced probe disguised as a comet. Loeb's team warns that this timing isn't a coincidence. It's an opportunity, and if this object is what they fear, that opportunity is intentional. The mathematics of orbital mechanics makes this window particularly significant. During solar conjunction, when Atlas passes behind the Sun from Earth's perspective, any course corrections would be completely invisible to our detection systems. This blackout period represents a fundamental vulnerability in our ability to monitor potentially threatening objects. Even our most advanced space-based telescopes cannot peer through the Sun's overwhelming brightness. It's a natural blind spot that any sufficiently advanced intelligence would recognize and potentially exploit. The duration of this invisibility window is what makes it so concerning. Unlike brief occultations that last hours or days, Atlas will remain hidden for nearly 3 weeks. That's more than enough time for significant trajectory modifications using advanced propulsion systems. When it emerges, we'll have no way of knowing whether it's still following its predicted path or has adopted an entirely new course. Within closed circles at NASA and the Department of Defense, whispers about a classified rapid response spacecraft program codenamed SHIELD 3 are growing louder. The plan, at least on paper, is to create a high-speed interceptor capable of matching 3I Atlas's trajectory far from Earth. The problem: no existing chemical rocket can reach the required velocity in time. Engineers are allegedly exploring hybrid propulsion, nuclear thermal systems, solar sails, and even experimental ion drives to close the gap. But every week lost makes the mission less feasible, and the funding for such an emergency launch has yet to be officially authorized. Insiders say there's an unspoken deadline. If 3I Atlas emerges from behind the Sun on a course that brings it closer to Earth, SHIELD 3 may become more than a contingency plan. It could be humanity's only shot at preventing the unknown. The technical challenges facing SHIELD 3 are immense. Traditional chemical propulsion systems, even the most powerful ones in our current arsenal, would require years to reach the velocities needed to intercept Atlas. Nuclear thermal propulsion could cut that time significantly, but such systems exist only in prototype form and would require extensive testing before deployment. Solar sail technology offers another possibility, using the pressure of sunlight to achieve high velocities over time. However, the acceleration is gradual, and the precise maneuvering required for an intercept mission would be extraordinarily complex. Ion drives provide efficient propulsion but at very low thrust levels, making rapid response scenarios nearly impossible. The most promising approach may be a hybrid system combining multiple propulsion technologies. A nuclear thermal stage could provide initial acceleration, followed by ion propulsion for course corrections and final approach maneuvers. Such a system would be unprecedented in complexity and would require international cooperation on a scale never before attempted in space exploration. The interplay between Webb's discoveries and exoplanet research opens new ground. Webb probes exoplanet atmospheres for gases like methane, carbon dioxide, and water vapor, clues to chemistry and climate on distant worlds. With 3I Atlas, however, Webb has added a complementary perspective: the solid remnants of planetary formation themselves. Studying both exoplanet atmospheres and interstellar debris creates a fuller view of alien systems. Atmospheres reveal present conditions, while objects like Atlas expose the raw materials that built those planets. Together, they provide a three-dimensional understanding of how worlds form and evolve. Atlas also speaks to galactic timescales. This object may have traveled for millions or even billions of years before reaching us, crossing interstellar clouds, brushing past nebulae, and enduring bursts of radiation from ancient supernovae. Its surface chemistry may preserve traces of those encounters, offering a timeline of galactic events. Webb's sensitivity allows astronomers to search for isotopes and compounds that point to cosmic rays, stellar nurseries, or explosive deaths of stars. In this sense, Atlas is a traveler carrying the memory of its journey. Gravitational choreography also plays a role. For an object ejected from another star system to enter ours, its path must align precisely with the Sun's gravitational reach, an uncommon event. Webb's capture of Atlas underscores how delicate these cosmic dynamics are. Slight changes in speed or angle could have sent it drifting unseen into the dark. Instead, it arrived within reach of humanity's most advanced observatory. This alignment raises both scientific and philosophical questions. Was it simply a rare fortune that Webb became operational in time to witness this object? Or does the timing suggest something more deliberate, an arrival calculated to coincide with our technological readiness? Such thoughts expand the discussion beyond astronomy, touching on how long our presence in the galaxy may have been noticed. As the date of its solar conjunction approaches, observatories worldwide are directing every instrument toward 3I Atlas before it vanishes into the Sun's glare. From its vantage beyond Earth's atmosphere, the James Webb continues to detect faint but intriguing signals, subtle fluctuations in light, unexpected spectral shifts, and a rhythmic pulsing in its dust emissions. Some view these as natural variations, yet the pulses show mathematical precision, with intervals resembling prime numbers or Fibonacci sequences. Such an order has drawn the attention of SETI researchers, who note that natural phenomena rarely produce patterns tied to universal mathematical concepts. Equally puzzling are the spectral changes. As Atlas nears the Sun, its surface should heat predictably, yet Webb records regions cooling while others warm, hinting at some form of internal regulation. The dust emissions also defy comet-like behavior. Rather than random jets, they appear directional and timed, as though adjusting mass or trajectory deliberately. Astronomers caution that once Atlas disappears behind the Sun, its speed, course, or even character could change. This brief window may be the only chance to understand its true nature. Increasingly, researchers feel the observation is not one-sided, that the object, in some sense, is observing us. The implications weigh heavily on the scientific community. Specialists trained to study natural bodies are considering the possibility of technology from beyond our system. Such a realization extends far beyond astronomy, touching planetary defense, human readiness, and our role in a potentially inhabited galaxy. In response, international space agencies are quietly coordinating, sharing data in real time. This level of collaboration, usually reserved for global crises, underscores the profound significance of Atlas's approach and the uncertainty surrounding what it might represent. Soon, the Sun will release 3I Atlas from its glare, and the world will be watching. If it reappears where predicted, it may fade into the dark as just another interstellar traveler. But if its trajectory shifts, we'll know something, or someone, has been guiding it. The James Webb has already revealed its form. The real question is purpose. Could this be a solitary machine drifting between stars, or the first stage of a plan set in motion long before we were capable of noticing? We may not get a second chance to prepare. In space, even a subtle change in course can speak volumes. Atlas's mathematical trajectory, anomalous surface materials, regulated temperatures, and rhythmic emissions suggest design rather than chance. If artificial, its mission remains uncertain. A benign possibility is that it is a scientific probe cataloging planetary systems and evaluating life. Another is reconnaissance, gathering intelligence on our solar system's resources, defenses, and inhabitants. The timing of its arrival, coinciding with humanity's leap into advanced observation, could be deliberate. The most consequential scenario is that Atlas is a precursor. In strategy, reconnaissance often comes before action. If so, its data could inform decisions about contact, exploration, or resource use. Its disappearance behind the sun grants the perfect moment to transmit findings. Any signals sent then would be masked by solar interference, hidden from our detection. When Atlas emerges, we may find ourselves facing more than just a comet. The James Webb Space Telescope has given us an unprecedented look at 3I Atlas, but it has also opened a door to questions that challenge our understanding of our place in the universe. Whether this object represents natural phenomena we don't yet understand or technology from another civilization, it demands our attention and preparation. The next few months will tell us whether 3I Atlas is simply the most interesting rock we've ever seen, or the herald of a new chapter in human history. Either way, we'll be watching, learning, and preparing for whatever comes next. If you enjoyed today's video, please give it a like and don't forget to subscribe to the channel. Your support means a lot to us. Thank you so much for watching, and we'll see you in the next video. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.